Welcome to Lesson 10.6, Line Symmetry and Reflections. Today we're going to talk about how to identify lines of symmetry and how to graph reflections. Right, a reflection is a transformation that flips a figure over a line. Right, so when you see your reflection in a mirror, what's happening is your reflection is you looking back at you, but it's your reflection being flipped over a line or flipped over an axis. That's why when you look at your reflection in the mirror, it's actually backwards. A line of reflection is the line a figure is reflected over. So if you look back here in the picture, we have the Washington Monument, and right here would be the line of reflection, and this right here is the reflection. So this is the transformation, this is the flip, and then this is the line that it's reflected over. So if you were to do an example in your notes, you could draw a square and then a square, and you could put reflection. And then do this same thing in your notes for line of reflection, and then point to the line. This is your line of reflection. Right, so when we're looking at the line of reflection, if this is the original image, okay, we can reflect it, and we can reflect it so it flips upward, or we can reflect it so that way it flips to the right or to the left. In this case, we're just going to look at the image that's reflected to the right and to the left. So I'm going to get rid of these. Right, so we reflected the image over this line. This line right here would be the line of reflection. The distance between this part of the figure and the line has to be the same distance as this part of the figure and the line. So everything has to be congruent and similar. It would just be backwards. Again, you can flip the reflection up and down. Same idea, has to be the same distance from here to here as it is from here to here. All right, when you're looking at reflections, we can talk about reflections on the plane. In this case, the image is a reflection across the y-axis. Okay, so it's literally which axis did I take and move this figure over to? In this case, I took it and I moved it over the y-axis. So this is a reflection across the y-axis. This is a reflection across the x-axis. I took the original figure and I shifted it and flipped it over the x-axis. So I'm deciding which axis would I have folded my paper on to create the mirror image. When you're looking at what axis you're reflecting on, that's only part of what you're looking for. Knowing what axis you are reflecting on helps you figure out your new coordinates. Right, so when you're looking at reflecting over the x-axis, I want you to take a minute and pause and see what you notice about your coordinates at each of your vertices. Right, what you should have noticed is that when you reflect over the x-axis, your y-coordinate is actually what changes. And it goes from being positive to being negative. So in this case, your positive 2 became a negative 2. Positive 2 became a negative 2. But if you look at your x's, those stayed the same. Your positive 6 became a negative 6. Your positive 6 became a negative 6. So when you reflect across the x-axis, your y-axis or your y-coordinates go from being positive to negative, or they can go from being negative to positive, depending where your original image started. Okay. On that same token, if you look at when you reflect across the y-axis, it would make sense that your x-coordinates are what changes. So in this case, you went from a negative 6 to a positive 6, a negative 2 to a positive 2, negative, positive, negative, positive. So you have to keep in mind and you have to remember when I flip across the y, my x changes. When I flip across the x, my y changes. All right, so how would I reflect this across the y-axis? Would it go from here to here or from here to here? If you said from here to here, you would be correct. Now I know that if this was a negative 2, 4, that my next set of coordinates should be, well, I flipped over the y, so my x changes. So now I should have a positive 2 and a positive 4. Let's check that out. Positive 2, positive 4. Then I should have positive 4, positive 2, 2, 3, 4, 1, 2, positive 4, positive 6, positive 7, positive 3. Notice the y isn't changing, only the x. And then positive 7, positive 5. Okay, now here we were able to check that, and we could have just figured out the coordinates from the flipped image. Notice the point here is 1, 2 away from the y-axis, so it has to be 1, 2 away from the y-axis here as well. Okay, same thing, this one is only 4 away, so this one can only be 4 away. You have to be really careful when you're reflecting your pictures because you want to make sure that your correct vertices line up. And sometimes that can be a bit tricky when you have shapes like rectangles and squares and triangles, so you have to make sure to take your time and plot your points carefully. All right, so now in your notes, you have this problem. So what I would like you to do, I would like you to post your answers to both problem number 1, the triangle, and I also want you to draw it, so you can draw it and then do your coordinates, or you can do your coordinates and then draw it. It's up to you. But you are going to have to know how to find the coordinates without doing the drawing for your test. And I also want you to do the rectangle as well and post both of those on Edmodo. So in this case, I apologize. In this case, this would be your number 1. And this would be your number 2. Okay, and just to quickly go over this with you again, if I'm going to reflect this across the x-axis, that means that my y is going to change from positive to negative. In this case, it is going from positive to negative because I'm in a positive quadrant for my y and I'm going to go to a negative quadrant for my y. So in this case, my new plots should be 5, negative 2, 3, negative 4, 7, negative 4, and 5, negative 6. If I flip this across the x-axis, I can check. I have 1, 2, 3, 4, 5, negative 2, 1, 2, 3, 1, 2, 3, 4, so 3, negative 4, and then 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3, negative 4, 7, negative 4, and 1, 2, 3, 4, positive 5, 1, 2, 3, 4, 5, 6, 5, negative 6. Right, so go ahead and try the rectangle and the triangle on your own and post your answers to Edmodo. Right, the next thing that we're going to talk about is line symmetry. Line symmetry is when a figure has a line that can be drawn through it so one side is a mirror image of the other. Right, so if I look at this triangle, I can draw this line through it, and if I fold it in half, this side matches up exactly with this side. The line of symmetry is the line through a figure that splits it into the two mirror images. So in this case, this line right here is the line of symmetry. So you can say this shape has line symmetry, and this is the line of symmetry. Right, so we have to decide, does this shape have line symmetry? If I draw this line right here, is it a line of symmetry? If you look at how it's folded, if I take this piece and fold it across, it does not match up. This corner comes up here, and because this corner doesn't match up with this corner, this is not a line of symmetry. However, if I draw a line through the center here, and then fold, this side does line up with that side and is a line of symmetry. And then the same thing going through the center horizontally, this side does line up with this side, therefore that is a line of symmetry. Right, so I want you to take a minute, pause, and determine if this dashed line is a line of symmetry or not. If you take this and you fold this in half on this dotted line, this side and this side do match up perfectly, so therefore this would be a line of symmetry. Since this is a line of symmetry, this shape does have line symmetry. Right, so then I believe that you have this one in your notes. So what I would like you to do is I would like you to pause, and I would like you to see if you can find how many lines of symmetry the shape below has. When you come back, we'll go over your answer. All right, this shape has a lot of lines of symmetry. You can go from opposite corner to opposite corner, and it matches up. Okay, but you have to go opposite to opposite. If you go here to here, that doesn't work. But if you go here to here, that works. Here to here, and you do have to make sure to line up those corners, otherwise that line of symmetry is not correct. And you could go from here to here. Now, you also have lines of symmetry through the center of each of these. So here, 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 and here. Now what's difficult about counting the number of lines of symmetry is you have to remember that this whole line is one line. So when we count, you really only count half of the way around. So we have 1, 2, 3, 4, 5, 6, 7, 8. If I count this one, I've counted that line twice. So if you counted 8 lines of symmetry, you were correct. Right. So what I want you to do is I want you to again try these. Pause. When you come back, we'll go over your answers. Right, you should have found that you have 1, 2, 3, 4 lines of symmetry on the square, and then on the triangle you have 1, 2, 3 lines of symmetry. So what I want you to post to Edmodo is if you found any connection between the shapes and the number of lines of symmetry. This is an equilateral triangle. This is a square. And this is a regular octagon. And I want you to post to Edmodo if you found any relationship between the shape and its number of lines of symmetry. The last thing I do want to look at is this right here. Okay, this is one of the state flags. We're going to see if it has any lines of symmetry. Now, as a shape, this does have line symmetry. However, if I split the flag right here, and I'm doing my best to split it in half, it does not have line symmetry this way because these 4 stars do not line up with another set of 4 stars over here. The pictures are what make this not have line symmetry. So sometimes you do have to look at the design on the inside. Same thing this way. If I split it down the center here, again, those stars don't line up, making it so there are no lines of symmetry for this figure. Typically, we will just be looking at shapes like this with no designs on the inside. However, I did want you to understand that if there is a design on the inside, that design does come into play. Again, you're posting to Edmodo your answers to number 1 and number 2, and then any connection that you found between regular polygons and the number of lines of symmetry that they have. If you have any questions, please make sure to write them down or post them to Edmodo so we can go over them in class.